And it's Thursday, and that means it's time for Matt's World of Weather.
And today he's taking a look at thunder and why it seems so loud at times, like I guess yesterday, right, Matt?
Right, and that's brought up a lot of questions. The thunder yesterday may have sounded a little different. Of course, it's been a while since we've heard the rumble of thunder on a consistent basis. But a lot of questions came in regarding just the sound, both how loud it is, but also the kind of sound the thunder had. So let's go over and talk about it. I've been bugging the control room trying to get Garth Brooks to play under this entire world of weather. But that being said, we'll go ahead as the thunder rolls. Let's go and talk about it. So basically, when you have lightning, you have thunder, and that thunder is sound. Speed of sound is about 767 miles per hour. Now, we'll talk more about that in a second. That is really important. The air around lightning is heated to about 54,000 degrees. For some comparison's sake, gold melts at about 1,000 degrees. So it just gives you an idea just how fast this atmosphere is expanding in a short amount of time. And that's why that thunder can seem so loud, and it can also hold on for quite some time with a slow rumble. So here we go. This is why it sounds kind of different. I got my lightning bolt on the left of your screen, then there's me on the right, down in my nice little outfit there. There's different parts of the lightning that create the sound, and depending on what type of atmosphere we're in, it affects how soon or how late that sound gets to my ears. Typically at the bottom part of the surface of the atmosphere, it's warmer. Sound will travel faster in warmer, drier air, or just in warmer air. Compare that to the top of the lightning bolt, the colder part of the atmosphere, the sound will travel slower, and that's where we get that rumble. You combine the two, and like on yesterday morning, if this bottom, warmer part of the atmosphere is a little bit higher, this rumble is going to last much longer. As we move a little bit forward, I'll talk a little bit more about that as well. So the closer to the lightning you are, the faster the snap, the louder it can be. The farther away you are, you get those soft rumbles. And like yesterday morning with that warm atmosphere, we could hear those rumbles from 10, 15 miles away. So a big thing is the temperature profile of the atmosphere determines the sound of thunder. And the other part of it is the wavelength. We can get more into that later, but the longer the wavelength, the lower or the softer that rumble is. The shorter the wavelength, the sharper it can be. So it gives you some kind of idea of the sound of thunder. Dave, Gina?
All right. Did I see a little weather badge on that sash of yours there?
Yes, sir.
All right. I thought I did. Thanks, Matt.
Sure.